Hello and welcome to another episode of 3-Minute Videos with Nathaniel. Today we will now solve question 1C of MAT Oxford 2013. We have these two statements about three functions. Find f prime prime 2x. How do we do this? First, we will make three more equations. The first equation we're going to make is f prime prime x equals to g prime x plus 1. You'll see why in a minute. G prime x plus 1 equals to hx. And finally, f prime 2x equals to g 2x plus 1. You want to see how I divide them? The prime is basically derivative. So taking a derivative will only change f prime x to f prime prime and gx to g prime x. Now you can see that this has an intimate relationship with this equation. Interesting, right? To find f prime prime 2x, first we have to substitute f prime 2x first. You can see here it's g 2x plus 1. So g prime 2x plus 1 equals to f prime prime 2x. Interesting, right? Because we take the derivative on both sides, then g prime 2x plus 1, this becomes h 2x plus 1 minus 1, as we see here. G prime x is hx minus 1 equals to h 2x. Wow, that's interesting, right? Well, we'll see why. Because we have f prime x and then we derive it, and then we use the f prime prime x to have the g prime of x plus 1. And then we have the expression of f prime 2x, which helped us. And we also have an expression for g prime x plus 1, so we substitute x for x plus 1 in both sides. So that means x plus 1 minus 1 becomes x. Miraculous, huh? Well, we often encounter these kind of equations in differential equations, like f prime equals g, g prime equals to h, and h prime equals to j, and j prime equals to f. Can you work out these four functions? This is a very simple differential equation. And you can see that f equals to sine x. This is not the only possible solution, but it's the simplest possible. Interesting, right? So these are what I call differentiation cycles, and basically I've actually found another similar equation that deals with second derivatives like this, including f prime prime x equals to f prime x squared. Interesting, right? Because most people often confuse dy over dx and d squared y over dx squared. Keep in mind that this dy over dx will be squared, which I sometimes confuse the two ones before, but now I don't, and I actually found a solution for this. Fx equals to 1 minus ln x. That's interesting, right? Anyways, I hope you will enjoy these differential equations and differentiation cycles and functions with strange differentiations or integrations that no one else thought of. And I hope you have a wonderful day solving another differential equation from MAT. If you ever encounter one, and goodbye!